Let's talk about the properties of the definite integral. If you look at this first property, I want to draw your attention to the fact that the lower limit of integration and the upper limit of integration are the same. So we're really looking at the area under a point. And the area under a point, there is no area under a point. So this is equal to 0. Okay. The second property is one that we use a lot. This one basically says if we interchange the limits of integration, you pick up a negative. So if you look over here, the difference between the right-hand side and the left-hand side is that these two limits have been switched. And when we switch these two limits, you pick up a negative sign. All right. The third property of integrals that we have is a summation property. So if we have the sum of two functions inside the integrand, then we can split it up into two pieces. Then we can write the integral from a to b of f of x dx plus the integral from a to b of g of x dx. The fourth property is very similar to the third property. It's just involving a difference. So the integral of a difference of two functions is a difference of integrals. So we can take the integral from a to b of f of x dx and subtract what we get when we find the area from a to b of g of x dx. Okay. For the fifth property, you'll notice that we have a constant times our function. So we can factor the constant out of the integral. So then this guy becomes c times the integral from a to b f of x dx. This sixth property is one that we've actually used before in an earlier example. Basically, if you integrate from A to C and then you go from C to B, that's the same thing as if you just went from A to B directly. So we can find the area is just going to be the integral from A to B f of x dx. So for this one, I can draw a picture to help you understand it a little bit better. Let's say that you have a set of axes like this, and here's A, and here's B, and here's C, and our function, something that looks like this. What we're saying is that you can find the area from A to C first, and then find the area from C to B, and that total area would be the sum of those two areas. Okay. So why don't we look at example 5, and we can use our properties to break this definite integral up and express the definite integral of negative 5x cubed plus 3x plus 1 over this interval negative 2 to 1 as the sum of three definite integrals. So the first thing I'll do is I'll write my definite integral. That's going to go from negative 2 to 1, negative 5x cubed plus 3x plus 1 dx. And then what I could do is I can use the sum rule twice. So I could split it up into three pieces. So that goes from negative 2 to 1, negative 5x cubed dx plus the integral from negative 2 to 1, 3x dx plus the integral from negative 2 to 1 of 1 dx. And why don't we actually take it one step further? We've already split it up into three definite integrals, but I wanted to use the constant multiple property, so I could factor out the negative 5. I could factor out a 3 like this. So my integral will become negative 5 times the integral from negative 2 to 1 x cubed dx plus 3 times the integral from negative 2 to 1 x dx plus the integral from -2 to 1 of 1 dx. All right. Why don't we also look at example 6? So when we look at example 6, they give us a couple of things that we know. We know that the integral from 0 to 8 of f of x dx is equal to 9, right? And we also know that the integral from 0 to 5 f of x dx is equal to 3. And they want us to find the value of the integral that goes from 5 to 8. So you see I put an equal sign because I'm already anticipating what's going to happen. I'm going to use that sixth property we described up above there. So I've got the integral from 5 to 8 f of x dx like this. So let's take a look at this. Using property 6, we can see that if I go from 0 to 5 and then from 5 to 8, that's going to be the same as going from 0 to 8. Now I know two of these integrals, and then I can figure out what the third one is going to be. So I know that on the left-hand side, we're going to have a 9. And on the right-hand side, for the first integral, that's going to equal to 3. And the part that I don't know is this integral from 5 to 8 of f of x dx. All I need to do is subtract 3 from both sides, and this tells me that I get the integral from 5 to 8 of f of x dx is going to be equal to 9 minus 3, which is equal to 6. Let's just put units squared just so that we recognize it's an area. Okay, so I'm going to highlight that answer, and that's it, folks. So we will talk about this stuff together in class, work through some more examples. Take care.